Ever since the launch of the James Webb Space Telescope, we have been blessed with stunning visuals of the universe like never before. In July, a puzzling new image of a distant extreme star system, surrounded by surreal concentric geometric rings, had even astronomers scratching their heads. The picture, which looks like a kind of cosmic thumbprint, came from Webb, and the internet immediately lit up with theories and speculation. Some even claimed it to be a Dyson Sphere, and evidence for alien megastructures of unknown origin. But what are these carbon-rich dust rings, and why is the discovery a major milestone in astronomy? Welcome to You Curious? Discover more, know more. Webb has managed to capture an image of the star Wolf-Rayet 140 and the 17 dust rings surrounding them, and the result is simply stunning. This particular story unfolds just over 5,000 light-years away from our humble planet, where a pair of stars have been locked in a cosmic waltz for a long time now. Destined to remain apart, every time these star-crossed lovers come close to each other, they emanate plumes of dust. And this dust forms ring after ring around them, with each passing, perhaps a testament to all the time they've spent pining for each other. The duo consists of an O-type star, roughly 30 times the size of our Sun, and its partner, the Wolf-Rayet star, about 10 times as big as our Sun. Wolf-Rayet stars were once O-type stars that are now nearing the end of their lives. But before they collapse and form black holes, they generate powerful winds that push huge amounts of gas into space, burning hotter than they did in their youth. And the Wolf-Rayet star and this particular pair may have shed more than half its original mass in this process. Now, every time the stars come close together, their stellar winds meet, compressing the gas and forming dust. And since the stars' orbits keep bringing them together about once every 8 years, the number of rings keeps increasing. Previously, we knew of 2 such rings surrounding the Wolf-Rayet 140. But now, thanks to the James Webb Telescope, at least 17 concentric dust rings have been spotted, evidence of at least a century's worth of stellar interactions. Further, some other Wolf-Rayet systems form dust, but none is known to make rings like the Wolf-Rayet 140. This unique ring pattern can be attributed to the elongated orbit of the Wolf-Rayet star NWR 140, unlike the circular ones seen in other systems. More than 17 exquisitely sculpted shells, each one a nearly exact replica, nested within the one preceding it. That means the oldest, outermost shell visible in the Webb image must have been launched about 150 years before the newest shell, which is still in its infancy and accelerating away from the luminous pair of stars, driving the physics at the heart of the system. With their spectacular plumes and wild fireworks, the Wolf-Rayet have delivered one of the most intriguing and intricately patterned images to have been released by Webb. The new study provides the best evidence yet that Wolf-Rayet stars produce carbon-rich dust molecules. Moreover, the preservation of the dust shells indicates that this dust can survive in the hostile environment between stars, going on to supply material for future stars and planets. Apparently, this was one of the first images taken by Webb, and has the scientific community at the edge of their seats. We now wait with bated breath for new cosmic wonders the technological marvel will reveal. And if you are a little disappointed that the rings did not turn out to be an alien megastructure, don't lose hope just yet. Because Webb has already started to examine chemical composition of exoplanets, and will soon turn its eyes towards our cosmic neighbor, Proxima Centauri. Recent astronomical discoveries suggest that billions of Earth-like planets are dotted throughout our galaxy, which is just one of billions of galaxies in the universe. Life may be present in abundance outside of our solar system, based on 2 simple facts. First, the chemical elements of life, such as nitrogen, hydrogen, and oxygen, are widespread in the universe, as are the 2 key compounds of life on Earth, liquid water and organic carbon. Second, we know that life was present on Earth very early in its history, soon after the planet was formed, which suggests that once the conditions are right, life springs up easily and quickly. If the origin of life is widespread, then complex life will be widespread too. And we might expect to find more than just single-celled microbes out there. intelligent alien life might have arisen and then perished. Some may have migrated to another planet or star system to escape the wrath of their dying star. There is one rule that has to be uniform across the universe for life in any form, and it is survival of the fittest. 4 light-years away from Earth lies the closest exoplanet detected till date, Proxima b. Some astronomers have found it potentially habitable, while others have blasted it for the intense X-rays it constantly gets pelted with by the star it orbits, Proxima Centauri. The exoplanet orbits 20 times closer to its star than the distance at which Earth journeys around the Sun, but because its star is a red dwarf, the energy levels it receives from Proxima Centauri are close to what our planet gets. This means that the temperature of the planet should be mild enough for liquid water to exist on its surface. However, there's any guarantee that creatures which didn't originate on Earth breathe oxygen and absolutely need water, but the conditions on our planet are what we have to go off of. And Proxima b is a tidally locked planet, which means that one side of the planet is always facing the star, bathing in solar radiation, and the other side in eternal darkness. Whether or not Proxima b could be a hotbed of life most likely depends on whether an atmosphere exists. Because, to support life, it would need an atmosphere that could hold its own against 400 times the X-rays that reach Earth. And if it has one, life could be thriving in the planet's twilight zone, the region between the day and night side. And amidst all the life nestled in her lap, Proxima b might give birth to an intelligent species. That species could harbor energy directly from the star by building a Dyson Sphere. That species could also be the source of the strange radio signals that we detected in 2019, coming from the direction of the star. While the Sun could provide them energy, it could also be the reason for their extinction. Red dwarfs produce stellar flares a lot more frequently than our Sun does. In 2018, scientists discovered flashes of light coming from Proxima Centauri that looked very different from solar flares. They were using a telescope that detects light at millimeter wavelengths to monitor Proxima Centauri, and saw a bigger flash of light in this wavelength. Astronomers had never seen a stellar flare in millimeter wavelengths of light. As such, scientists wanted to learn more about these unusual brightenings in the millimeter light coming from the star, and see whether they were actually flares or some other phenomenon. They used 9 telescopes on Earth, as well as a satellite observatory, to get the longest set of observations, about 2 days' worth, of Proxima Centauri, with the most wavelength coverage that had ever been obtained. Immediately they discovered a really strong flare. The ultraviolet light of the star increased by over 10,000 times, in just a fraction of a second. If humans could see ultraviolet light, it would be like being blinded by the flash of a camera. Proxima Centauri got bright really fast. This increase lasted for only a couple of seconds, and then there was a gradual decline. Such massive flares basically erode away a bit of the atmosphere of any planets orbiting that star, including this potentially Earth-like planet. And if you don't have an atmosphere left on your planet, then you definitely have a pretty hostile environment to life. There would be huge amounts of radiation, massive temperature fluctuations, and little or no air to breathe. It's not that life would be impossible, but having the surface of a planet basically directly exposed to space would be an environment totally different than anything on Earth. And that's why, for a civilization to grow and thrive, they will need to make the night side their home. Scientists believe that they would build massive mirrors and have them levitate in the air to capture light and solar energy, or they could build massive LED lights to illuminate their world. Observations from Earth so far tell us that the chances of life on Proxima b are slim, but not ludicrous. And we will soon find out more about the planet, once our technological marvel turns its eyes towards the star system. The James Webb Space Telescope will not only be able to capture the star and its planets, but also study the atmospheric composition of Proxima b to find telltale signs of life. If there are any artificial lights, Webb will be able to detect them too. And if Proxima b is truly habitable, then humanity has a planet nearby where we can settle, or make it our second home. To become a multi-planetary species, discovery of life. On Proxima B will change everything for humans. Now, we just wait and watch. What do you guys have to say? Drop in your comments below, and don't forget to subscribe to You Curious. Discover more, know more.